and welcome everybody to the May 2025 VJUG live session. I'm Kim Fletcher and I'm one of the VJUG organizers. If you're new here, welcome to the Virtual Java User Group. We're a global Java community bringing together high quality tech talks and speakers from around the world. So let us know in the comments and in the chat where you are dialing in from today. For today's live session, please do drop your questions and comments in the YouTube chat. And if you're watching this after the live stream, please join our Slack channel. And I'll be sure to drop this link in the chat as well for you. And you can go and ask all your questions there as well. And it's also the best place to connect with the rest of the community. So now let us welcome your host, Billy, and speaker Venkat for today's session. Welcome, both of you. So excited to have you.
Hey, thank you for having us.
You are most welcome. I know there's a lot of people who are waiting and excited to hear from you. So take it away.
All right. All right. Yeah. So thank you, Kim and Venkat, for having me. I'm very happy to be hosting this this VJUG session. And it's going to be about a very interesting topic, stream gatherers, which were just added back in JDK 24, which was released back in March. But yeah, without much said, I'm guessing, Venkat, you need no introduction. So I will go ahead and bring on your desktop, and you can kind of go ahead and introduce your subject as well as what people should be asking about. So, and also, as I already mentioned in the chat, please ask questions. I will be happy to kind of, Venkat and I, we talked about wanting to make it interactive. So as you have questions, definitely feel free to ask him, and I'll make sure to ask Venkat.
Thanks, Billy. Appreciate it. Thanks, everyone, for joining. This is as new as it can be. This is about gatherers, and I'm excited about this particular topic for a couple of different reasons. So let's dive in. Well, we've been using functional pipeline in Java for quite a while, introduced in Java 8. Let's take a look at a functional pipeline really quickly before we get into the core of the topic. So let's say for a minute we have some numbers to begin with is equal to, let's say, list of, let's just throw in a few numbers in here. So given these numbers, we could pretty much say we can take numbers.stream. We could perform a map operation, for example. So we could say in here, a map given an element, give me element times 2. We could do a for each on it. And then we could say, given an element, output the element. Sure, we could use a method reference. That's not relevant for this conversation right now. So let's go ahead and run this code, and we can see the elements being printed as double the value, as you can see in here. Well, this is a general pipeline that we all are used to. But most notably here, we got two sets of operations we need to pay attention to. One is the terminal operation. And the terminal operation is the one that triggers the evaluation of the pipeline. And of course, the other one is the intermediate operation. You could have multiple intermediate operations, as you already know. So for example, you could say, given an element, you could say in this case, element mod 2 is equal to 0. Then I want to only double even numbers and print them out. So in this particular example, this is also an intermediate operation, as we all can tell. So essentially, that's a pipeline as we know it. And as Billy said, please do ask your questions or post your comments along the way. We want to make it as interactive as we can. So please don't hesitate. Any time is a good time for your questions or comments. Well, we already have a way to create a custom terminal operation. We have used this quite a bit in the past, isn't it? So for example, you could say a var result is equal to, and instead of the for each in here, you could have said a dot collect. And in this case, you could say, for example, a to list. And obviously, you could use a to list directly right now, or actually, why not a to set, just to make it a bit different, if you will. So you could call the to set method and then output the result in this case. So for us to take a look at it. Now, in this particular case, as you know, you could create your own custom collectors as well. So we already have a way for us to create custom terminal operations, and that's been provided since Java 8 timeframe already, so we have all been used to it. But the question is, what if you want to create a custom intermediate step? So essentially, let's say right in the middle of this, you want to do some custom intermediate operation. How in the world can you perform a custom intermediate operation? Well, until Java 24, as Billy mentioned, there was no way to really do that. And we were stuck with what was given. As an example, in Java 8, we did not have, so as you know, right, we already have a function called the limit function. So you could do a limit and you could say only two elements, please, right? So you could do a limit. But what if you really wanted maybe not a limit, but a take while function? Well, as you know, a take while can say, while element is less than, let's say, 3, for example. Well, as it turns out, this was, maybe I could say a 4 here and just run through that, or a 5. So you could try different operations, but this was added in Java 9. Now think about it for a minute. Imagine you were in Java 8 and you did not have take while, but you wanted really to use take while. I used to get emails from people asking how to do that, and there was no really good way to do this. Now imagine you have other operations, intermediate operations you want to do, but they are not part of the JDK. So the question is, how do we create our own custom operations that are intermediate? That's exactly what gatherers provide us for us. Well, Victor Klang and the group really came up with a brilliant way to accommodate this by providing a gather method in between. But we'll get to that a little later. But let's take a little sample and work through it to see what this is going to provide. So let's take a stream, if you will, for a minute. But in this case, let's call the reduce method. And let's say we want to start with an integer and a sum operation in here. And this gives us a result, and we can output that result in here, as you could imagine, right? So we can just output the result in here. We've had this in Java 8. So the reduce allows us to perform a fold left operation. In this case, it reduces this to the sum of all the elements in this collection. So 1 plus 2 plus 3 plus 4 and so on gives us a value of 21. Well, that's great so far. However, the reduce is only giving us one result in the very end, which is the total of all the values. But what if you want to have a running sum? I want to have a value of 1 and maybe a 3 because 1 plus 2 is 3, and maybe a 6 because 3 plus 3 is a 6. And then I want a 10 because 6 plus 4 is a 10. So I want a running total along the way. So the question is, how can we accomplish that is the question. Well, this is where a custom step is needed. But again, they provided a bunch of built-in gatherers for us to be able to use it. So we want to be able to emit these intermediate results of the reduce, and that's a scan function. And so this is built on gatherers, but this is a a built-in gatherer. So before we go off to create our own custom gatherer, I recommend you see if there are any built-in gatherers that you can immediately use. So in this example, I'm going to take the numbers, and in this case, we'll bring in the stream again. But this time, I'm going to say gather. We'll come back to that in a minute. And a for each and a system.out, and I'm going to print it right now. Now, without this particular, gather function, as you can see in here, what we're going to have is those values being printed, as you know. So all those values 1 through 6. However, I'm going to introduce a gather step. But what am I interested in doing in the gather step? I'm going to say gatherers. So we'll bring in the gatherers dot, and notice there are a few built-in functions available. There's a scan, there's a fold, and so on. I'm going to take a scan function. So what's a scan function in the built-in gatherers? Well, scan allows you to perform the reduce, but emit the data as you are reducing. So in this case, I'm going to say we'll start with an initial value of 0, but perform the integer sum. You can relate this to the code we saw up here in this particular function. So what we are dealing with in here when you run through this is, notice that running total I mentioned earlier. So 1 and then 3 and then 6 and then 10. Well, how do we get those results? Well, obviously the first value 0 plus 1 is 1, and 1 plus 2 is 3. 3 plus 3 is 6, and 6 plus 4 is 10. So that's a running total that's being emitted. So what the gatherer allowed us to do in this particular case is that it allowed us to emit the result of this reduce operation, but intermediate values being emitted, and not just only the final result that reduce provides, but it gives us the intermediate results as well. Well, that was accomplished using semi-custom, I mean, if I could use the word, because it's a built-in gatherer that they provided, but this also gives us the gist of how this is going to work. So the gather function is the function you would use to introduce a custom intermediate operation that's not already built into the JDK. Well, let's go a little further with this. So what does the gatherer really do? Well, let's understand a fundamental of how this gatherer is going to work. I want you to think about the functional pipeline again. So in a functional pipeline, what you really have is the source, but you can have a stage 1 and a stage 2 and a stage 3 and so on until you hit the terminal stage, if you will. The stage 1, stage 2, and all this are intermediate stages, as you know. So what does the stage really do? Well, keep in mind, a stream is lazily evaluated. So what that means is, if you have an intermediate step, like a map or a filter, it may or may not run based on what the terminal step is going to say. For example, instead of the for each, if you had a find first in here, as soon as the first element is found, no further elements are processed. So the question is, how does it know not to process more elements? So this is where we get to a fundamental of how the stages are going to work. So a stage is going to process the value given to the stage. It's going to then maybe optionally push the value downstream. So when you look at it, a stage may say, I did my work, whatever that work is, and now that I'm done with my work, I'm going to push the result to the next stage downstream. So one operation of a stage is to do the work and push the result downstream. However, the downstream after processing may say, I don't want any more of your results. Like in the case of find first, the minute it gets a first result, it says, I'm done. No need to do any more work. In the case of a limit 3, as soon as 3 values are sent, it's going to say, I'm done. Don't send me any more. So that is where it needs to convey the desire to the upstream as to what to do to move forward. Let's look at this as a picture, if you will. So here is a stage, and this is an example of a map function in this stage. It gets an element, it performs its transformation, pushes it down to the downstream operation or stage, and asks the downstream, what do you like to do? Do you want more elements or you're done? And whatever the downstream says, it's going to return back to the previous upstream. Now, this is the case of a map. If this was a filter, what's going to happen? Well, the filter may optionally pass some data downstream. What if this was a limit kind of a function? Well, it might itself tell upstream, don't send any more data. So the upstream can know what to do either based on what a downstream stage or operation says or what your stage itself says. So that is something we need to really understand as a fundamental, is that every stage does its work, pushes data downstream, takes the result from the downstream, whether it needs more elements or not, makes its own decision optionally, and sends it to upstream to say what to do for sending more elements or not. We're going to see this in effect as we look at more examples along the way. So let's get a little bit more complicated in terms of the next operation we want to see.
I
So let's,
guess one
oh, yes.
question,
Oh, of course.
just a question for me, just to kind of get it a little bit started, and you're maybe about to answer it, but
Yeah.
are you able to combine multiple gatherers together and also count, and then there is no limit? So like, let's say I have like, if I maybe could do multiple gatherers and I have a limit at the end of there, does that always communicate all the way up, or is there a limit to how much
Yeah.
that upstream communication does?
No, fantastic question. Before I answer that question, Billy, let me talk about software design fundamental for a second. I'm a big fan of cohesion, right? So the question I would ask is really quickly, would I combine multiple filters, for example, together into a complex, check? Or would I typically do a filter, check one and a filter check two? Generally speaking, right, there are always exceptions to what we do, but
Hmm.
generally speaking, I would have different filters. The reason is it makes the code more cohesive in general. Well, the same rule I use for this as well. I would bring a gather one more time, and the second gather would do its intermediate operation. The benefit we see from this approach is makes the code cohesive. It
Hmm.
also becomes a lot easier to comment out just one part and experiment with it. It
Yeah.
doesn't make the code more complex as well. And also we can intermix gather with other phases as well. So if you had a filter right here, that's perfectly fine. Also, you can intermix gather with the filter or a map or limit and so on. So you can have any combination of those. And
Nice.
the beauty of this is every stage is so to say independent of the next stage, so that
Mhm.
they're all isolated, so everyone can make a decision and convey to the next stage that makes its own decision and conveys upstream whether it wants more elements or not. So absolutely, this is extremely extensible in terms of its capability. So really
Yeah.
good question, and you're absolutely right
So
that
like
you
you could
can
do like a
combine.
gather, a limit, and then another gather, and then a filter, and kind of going through that for if you were really kind of working through like a really massive stream. It's like, okay, I want to get, gather this, get the first 100, do some other operation. You can just really kind of combine these all together instead of having complex
Beautiful.
logic. Yeah.
Absolutely, absolutely.
Yeah.
And what should determine that is the domain, the business that we are trying to solve, and the Gather API gives us that flexibility to do the way we can to solve our business problem. So the answer I would say there is when you sit down with your business analyst and you walk them through the pipeline, are they nodding their head saying, "Yep, that makes sense from the business point of view"? Because one of the benefits of this is the code is much like the problem statement when we are writing it properly. So when the business people are looking at this and saying, yep, that really makes sense, that's exactly what we want to do in our business, then you know that you're aligned with what the business expectations are. So absolutely, a
Perfect.
beautiful, beautiful thought.
Yeah.
Yeah.
And we actually have a question here.
Yeah.
Oh wait, hold on. That's not work. Here we go. Let me show it on here from Divyanas. Hopefully I'm pronouncing your name correctly. But could you please give a scenario where a filter and a gatherer both make sense, such as where the filter is limited and gatherer is required?
Oh, you
And
bet, you bet.
yeah,
Yeah. Thank you, Divyansh. And the filter is basically to say that we want to process some element or discard them. So you could say, taking this example for a minute, you could do a filter and eliminate all the non-even numbers, and then the gather could be doing the scan operation where you're only summing the values. So that could be a direct example, right? So you could go back to this and say, hey, if I run this code, you can see that it's emitting the sum of all the values, but I don't want the sum of all values. So I'm going to simply do a dot filter right in here and say, give me only even numbers in this collection, and I want only total of all the even numbers, but keep emitting them along the way. So that's an example right there. So we could use a gather after filter or a gather after map, and any combination that you may have based on your business needs. So absolutely, you can come up with different use cases for doing such things depending on what you're trying to do. That's very flexible, as you can see. Absolutely.
and there's one other question here, and this is kind of
Mhm.
maybe for you to give a bit of your own opinion. Will be interesting to see in the future if we can create a lot of gatherers or sell. This is from Martin Blumberg.
Mhm.
Uh, will be interesting to see if in the future if we can create a lot of gatherers ourselves, or if we would have enough to add another couple of intermediate methods that we're missing. So I think they're kind of maybe asking, like I think there's what 4 gatherers that we have pre-built in. If we're gonna then it's like that is. Do you think we should add more? We being the JDK team, or do you think that kind of is enough and we can kind of go from there on whatever we need?
Yeah, absolutely. A brilliant question, Martin. And the answer to that is going to be pretty much based on common usage. So if something is, here's a way to think about it, right? Even I would argue sometimes it's not even a not even a built-in gatherer, but even a custom function within the pipeline. So you have 3 possibilities now. Maybe just like a takeWhile was added, it can be a function in the pipeline directly, like the to list was added eventually, right? So
Hmm.
that's option one. Option two is we could have a built-in gatherer. And option three is, hey, you're on your own, programmer, go figure it out. So the answer to that question really will come down to how common this one is going to be perceived as. If it is extremely common in functional programming, you could say it should be directly on the stream. If it is not as common in functional programming, but common in usage patterns, I would say it should be a built-in gatherer. If it is more domain specific, it should be a custom gatherer we implement as programmers. And I think time will tell that. So as programmers, if we find more and more of us are using something, and if we see that it's emerging in libraries, eventually the JDK team may look at it and say, gosh, this is in a third-party library, because it's used so often, let's absorb this into the JDK. That could potentially happen as well. So I think that we're going to learn from the time to decide that, I think, as time goes on.
Yeah, and there's definitely been some cases where that has happened. Like for example, like the changes to how we do dates and stuff. Like at first that was done in Jota time, and eventually that was then propagated up into the JDK. So one other question: is there a performance, or is there improvement in performance with using gatherers versus maybe other ways of working through streams? And yeah, if you could explain that, if there is or isn't.
Yeah, and that's a really important topic to consider, Thirumalesh. And the reason for that is when you are implementing the custom gatherer, you are taking the responsibility for the operation, and you're no longer under the guidance of the JDK team. So if you implement the gatherer really effectively, it's going to give you good performance. If you implement it poorly, it's going to give poor performance. So the answer is it depends on how well we do this. The gatherer itself, obviously there's going to be a little bit of overhead that gatherers is going to add, because that's a step where it's got to delegate to your operation. But that performance itself is not an impactful one. It's about what we do in our code. Also, a little bit further, we need to think about the different types of gatherers we implement can make a big difference as well. Whether you implement a parallel or sequential, that can make a big impact. If something is being processed in parallel and you inject a sequential step in it, you are bringing them to a grinding halt, right?
Yeah.
And here's a way to think about it. I like to use the analogy to think in a little bit different way, if you will. So I want you to think about this like traffic flow on a freeway. That becomes a little easier to think about it, right? We all live this, so we know. Here's a freeway where there are, 4 lanes. Traffic can go independently on those lanes. But imagine a freeway with a construction zone. We all hate those, don't we?
Yeah.
Now, all these cars have to line up and they have to pass one at a time before they can again switch lanes and go in parallel. That's exactly the situation in gatherers. That's why I like this question that Trimalesh asked, because it depends on what we want the gatherer to do. So in a parallel operation, you may bring that to a grinding halt with the sequential step in between. But in all fairness, when you do a sort phase in a pipeline, you're going to do similar things as well, right? So it's not like this is only because of gatherer, but
Hmm.
much more so, we need to really think about it and decide what the consequences are. So if performance is extremely important, you need to weigh in. But I always say correctness is more important than performance. So it's got to be correct from the domain point of view,
Yeah.
then address the performance. But your concerns are legitimate concerns. And the unfortunate answer for that is we have to understand what we are doing to decide on the impact of performance that it may have on it. So something for us to really think about, if you will.
Yeah, that highway example can kind of helps clarify like what is going on there, and perhaps also to kind of continue. It's like maybe if you were able to like say move up a sort to kind of remove some of those items from it, if possible, that could kind of help. Even if because like to what your point is like you can't put performance above correctness. So like you can't be like, well, this is going to give the incorrect results and not do something right, but it's more performant. Like you can't do that. But if there is some ways you can kind of work it around to get a bit better performance, that could
Right.
be good. Okay, so one question, and maybe I'll can let you continue the presentation here a little bit. So like let's say we put together a bunch of gatherers or a bunch of different operations really in general, and one of them throws an exception. How can we maybe handle that?
Yeah,
The old
that's an easy
exceptions and
question.
streams.
That's
Yeah.
an easy question. And Vikram, we don't have to talk about gatherers to answer that question. And the reason for that is functional programming and exception handling are mutually exclusive. And the minute we try to mix them, we have invited more trouble than it's worth it. So I would say the problem is no different than you deal with this without gatherers. So my general recommendation is if you have a lot of exceptions to deal with, you are better off programming an imperative style than to use functional style. So that one is the easier question that Vikram is asking, because that's the problem with functional programming, not with gatherers, if you will. Awesome. So I want to show
Sure.
an example of creating and then thanks for all those questions. I really appreciate it.
Absolutely.
So I want to talk about a way to create a custom gatherer, but I want to do so with something familiar so we are comfortable in seeing how this actually works. Now, you would never, ever create a custom filter, right? That doesn't make any sense. So this is for a demo purpose only to understand how this works. So we take something familiar and then see it in the light of gatherers to get a better understanding. So let's go over here to look at an example of creating our own filter rather than using the built-in filter, if you will. So what I want to do here is let's take these values up to 7, let's say 8, 9, and 10. But in this case, I'm going to say numbers.stream. But let's go ahead and say gather. But to this gather, I'm going to say a custom filter. So I'm creating my own filter, which is going to return only the even numbers in the collection. Then I'm going to limit this to a value of 3 only because we can. And then I'm going to say a for each, a system dot out, and I'm going to do a print line on it. So I want to create my own custom filter function here that I'm going to send to the gatherer. So what does the gather function actually do? Gather function receives as an argument a gatherer, which is an interface. That's what it receives as an input. So all I'm going to do here is to create this function. As you can see, we're going to clean this up a little bit. We'll just accept it for now, but we'll come back and clean it. So what are we doing in this function? This gather here simply says, I'm going to receive an integer, and I don't care about the state. While gatherers can be stateless or stateful, I'll talk about this a little bit more a little later. And in this case, I'm going to say this is going to be an integer as well that we're going to bring in. But the custom filter receives as an argument a predicate, which is going to take an integer. We'll simply call it as a predicate. So that's what we want to bring in here as well. So we brought in a predicate, and as we know, that comes from the Java util stream util function predicate. That's what we are bringing in right there. So now what do we do within this particular function? Now remember, this is going to say return gatherer dot off sequential or off. So off sequential says this stage will run sequentially. Off means this stage can run in parallel as well if necessary. So if you're using an off sequential, that's the bottleneck I talked about. In a parallel execution, that's going to bring everything into a sequence and run it. Off itself will run it in parallel if you already are in a parallel stream. So off sequential is sequential no matter whether you're in sequential or parallel stream. Off will be parallel in parallel stream and sequential in sequential stream. So in this case, I'm going to say off sequential. And what do I want to do with this particular function? This is a helper method to create a gatherer more easily. So you don't have to put a lot of effort to do a new and create an anonymous inner class. That's a lot of work, isn't it? So the first argument is the state. This is a stateless gatherer. There is no state to carry over. An element you are interested in, and a reference to the downstream, pardon me, that you want to work with. So state, ignore that for now. We'll talk more about it later. Element is the element being processed by this stage, and downstream is a reference to the one stage downstream. So what are we going to do in here? Well, I'm going to simply say in this case, a predicate dot test on the element. So what does this do? If the test is true or the test is false. If the test is false, what do? I simply return a true to the previous stage, saying, hey, I process this element. I don't want to push this down to the next stage. Give me the next element, please. So that's why we return a not of that. So we return a true to say, give me more. If this returned a false, if this returned a true, then what do? If it returned a true, that means we need to push this to the next stage. So we say downstream dot push and the element like so. But remember, downstream push returns a true or a false. In other words, it's the wish of the next stage. So keep in mind, this may return a true if this returns a false to say, hey, upstream, give me more, or it returns whatever the next downstream says. If the downstream says, give me more, we tell the upstream, give me more. If the downstream says, I don't want any more, we tell the upstream, false, I don't want any more. So we either ask for more if we did not process this element to go to the next stage, or if we push it to the next stage, we convey the message from the downstream, up to the previous stream. So going back to this example, we are doing the processing and telling the next downstream, go use this. Whatever you tell me, true or false, I return to the caller. If I decide not to push to the next stage, I will simply return a true saying, give me more elements. That's basically what we are doing here with our custom filter. So let's go ahead and run this code and notice we got only the even elements from this filter. So we wrote our own custom filter. This is not doing anything different from the built-in filter, right? So you got to know not to do this in reality, but hopefully this gives you an example. Billy, what are your thoughts?
Yeah, oh, I guess one is there's a new feature you're also showing off here, or at least a newer feature, post 21, the underscore. I don't know if you would maybe want to explain that. And then we also have another question from the audience as well.
Oh yes, so I'm glad it's almost things I didn't even recognize because I've gotten so used to it. So a brilliant point. So the underscore is the international symbol for I don't care.
Mhm.
So that's basically it's an IDC, right? I don't care. So we don't want to talk about it, so we use an underscore. So it's irrelevant to this conversation, and that's what we mean by underscore. So I love the underscore. As you know, underscore was removed from the usage in Java 8, 9 timeframe,
Yeah, yeah.
but then it's been reintroduced now. So you're absolutely. So you don't have, when I program, usually I use the word ignore to say that I'm not using it,
Mhm.
but I would rather use an underscore because you can use it for multiple parameters as well. So
Yeah.
you can use it multiple times. Yeah.
Yeah, it's definitely a nice feature. Also, if anyone asked, there is no performance benefit to this. Like within the JVM, there's like an anonymous weird variable name that'll be added to it, but it is very good. To your point, it's like it's the international symbol for I don't care what this means, which is also then great for going to the future.
Yeah.
So a question from the audience from Santiago goes, could you use anonymous class format, please, to see what method is being implemented, or does anyone know which functional interface is being implemented? So I think he was just, yeah, going back to the custom filter that you were working on just a few moments ago.
Yep. So I'm assuming the question Santiago is asking is, what is the anonymous interface? Sorry, what is the functional interface we are implementing for the gatherer itself? So in this case, it's the gatherer is the interface that we are
Mhm.
implementing. And internally, though, it doesn't have to be an anonymous inner class. We could be leveraging invoke dynamic for all practical purposes in this particular case. So that's an implementation detail. But in reality, it is that interface that we are really working with is the gatherer. And the beauty of this is the gatherer itself contains multiple of these functions. A lot of them are default, except for the integrate is the only function that's required. That's why it's a functional interface, as you were suggesting. But in this particular case, this is going to perform the stages operation, which is going to be multiple different operations, right? It's got to initialize the stage. When it's a stateful, you need the initialization to know what state to inject in the beginning. Integrate is your operation, what you're doing. A combiner and a finisher are really useful in a parallel execution. Again, going back to this example I had in here, you could say that's where the combiner and the finisher comes in. If you do have multiple of these running in parallel, you need to combine the results of them and finish up and send the result to the next stage. That's where the combiner and finisher comes in. A very complex interface, nevertheless, but all that is nicely tucked away under the off sequential, so it reduces the burden on you quite a bit by using this utility function to create the gatherer, if you will.
Nice. So yeah, I got a few more questions from the audience. So this is maybe a bit of code standards and also the old it depends. So Dr. Venkat, I thought from Salim, I thought you don't allow curly braces and lambdas. Now every Java developer will open them up in Gatherer. So I guess kind of
Oh, brilliant question, Salim. That is why I don't have the curly brace here. Billy, when I was writing the book, I was so angry at myself because it was so easy to put a curly brace and write multiple lines. So my recommendation is, if you do have a need, and to Salim's point, if you have a need to do more work, I would call an apply predicate function right here. And the apply predicate will take the predicate, take the element, and downstream. And in that case, the apply predicate function will contain those multiple lines of code. So this is going to be I would just put this as a comment here, multiple lines of code goes here. So to Salim's point, Java, Billy confirmed to me this if it is true, but the JDK doesn't ship with discipline, right? So
No.
that is something we need to have as programmers. So I think it's a discipline on the part of us, the programmers, and code reviews in the team. To Salim's point, no, not every Java programmer has to do this. With enough discipline and encouragement from our code developers and our team, we can have the discipline to write a function and then invoke that function within the Lambda rather than using a multi-line Lambda. And thanks for knowing that, Salim. I really appreciate that. You made my day, I would say, because I cringe anytime somebody puts a curly brace and writes multiple lines of Lambda. Definitely you want to avoid that. And a little bit of discipline can take a long way. So hats off to Salim for asking that question, because it's a reminder for everyone that we can still have discipline to write good quality code and don't have to just accept it just because we saw a demo where somebody put in multi-line Lambda. We can do better. So my recommendation is, write your multi-line code and then call that function within your gatherer. I know it's a little bit of an extra effort, but the future you will thank you for having that discipline, in my opinion.
Nice. Okay, and then another one is, do gatherers work with optional and completable futures?
Absolutely. So there shouldn't be any reason for that at all. But the answer is, you can use optional, and I wouldn't go to the extent of completable future. I'll remove that from this discussion for just a second. So the answer is yes, optional will work definitely. But I would argue the reasons to use completable future with streams is really far less. And also moving forward, thanks to virtual thread, which is a completely different topic than this one, I would say I would shy away from using completable future, because virtual threads are much more superior for that problem that we solve than completable future. So ignoring completable future from this discussion, I would say optional. Absolutely, you can do that as well.
Nice. And then one last question before maybe continuing on a bit here. So let's say if you're not quite in the future yet, you're still in the pre-JDK 24 days, is there an alternative to implementing some of the examples you've shown, if you don't have access to gatherers, such as, explain with like one sum incrementally each element and then push parcel results downstream?
Yeah. So there are two answers. One answer you're not going to like, which is to upgrade, right?
I like that answer.
I'm not sure Victor is going to like
you're
that
talking
answer.
Victor, yeah.
Yeah. And the other one is, you can implement those as multiple different operations. If you remember, optional gave us a stream function, so you can combine multiple streams together. So you can call find first, and then you can call a dot stream on it, and then you can do another stream operation if you want to. It's not going to be efficient, it's not going to be elegant, but the answer is you can. The other thing I also would encourage developers to think about is, I don't think a lot of developers have explored this, Billy, is the use of the T function. I'm a big fan of the T function as well. Sometimes we can combine multiple operations in T. I know that's a bit more complex code to write, but it's worth exploring it. So I don't know if a particular problem will be solved by the T function, Victor, but I would say explore that to see if you can squeeze it into T operation. It may not be as elegant as using a custom gatherer, but it's worth a shot, if you will. And if all that fails, then you're just going to write multiple steps to perform the operation, unfortunately, I would say.
Perfect. All right. Yeah, I will. Yeah, that's all the questions I think for right now. So yeah, I'll kind of let you continue on with your presentation.
Cool. Thank you.
Sure.
Again, I appreciate those questions and comments. I really appreciate that. So, I want to talk a little bit about the flavors of gatherers before we jump in and talk about two more examples in here. So, when it comes to gatherers, there are two dimensions you can look into it: a sequential versus parallel, and a stateless versus stateful. And you can mix and match these things, if you will. So, for example, a stateless gatherer doesn't bother about the value between elements. So every element is considered independent. Filter, map, they are stateless. Limit, and then you can think about limit itself as a stateful, right? What does limit do? Limit says, oh, I sent one element, two element, three element, stop. Well, how does it know you sent three elements? It gathers the state, right? So there are stateless like filter and map, stateful like limit, for example. Sequential runs sequentially, and if it's stateless, it doesn't manage any state. On the other hand, if it's stateful, it runs sequentially because it's sequential, but carries the state from one element processing to the next element processing. A parallel, on the other hand, allows for a parallel execution, and if it's stateless, doesn't manage any state. It allows for parallel. So if you're in a sequential stream, the parallel doesn't make it parallel. Keep that in mind. It's parallel when you're in a parallel stream. When you're in a sequential stream, it's going to be sequential. On the other hand, where parallel with stateful allows for parallel execution, but carries state and manages the merging of the data as well. You can also look at this in a slightly different way. This one is the easiest to implement. This one is where you are asking for a lot of pain. So if you enjoy a lot of pain, this is what you want to implement. If you don't like as much pain, you want to move in this direction to lower the pain. So think about it like a wave. So painful, less painful, much less painful, easiest. So again, in all fairness, it depends on your domain. But if you don't need to go towards the right bottom, don't go. If your problem can be solved by being on the left quadrant or to the top, it's much better. So you want to really minimize the pain as much as you can. Keep in mind also, when I say pain, it's not just the more effort, it's also more chances of errors, more chances of performance issues, and so on. So the more we do, the more pain we can cause and trouble as well. So be a little mindful of what you actually do, because it may not be the best thing to do in general. But having said that, let's take a look at an example just to understand the sequential. Remember, sequential will run sequentially no matter which kind of stream you are in. If you're in a sequential stream, sequential will run sequentially. If you're in a parallel stream, sequential will run sequentially. Why do I care about it? A good way to understand this is with an example, and let's talk about peak function. I know most of us may have used the peak function, but it's important to understand the limitations of the peak function as well, so we can appreciate this quite a bit, what we can do with it. So let's go to a stream and let's do a for each right here. And I want to just swallow that particular value so we're not displaying any results right in there. So now I want to show you a peak function. So here's the peak. And what does the peak function do? System.out, and I'm going to print line it so we can see the output of the values. As you would imagine, the peak is going to display the values for us. So this is used for debugging purposes, right? So 1, 2, 3, 4, the values in the order. But if I change this to a parallel stream, then what's going to happen? Well, clearly, there is no ordering on the output, as you can see, because a parallel stream, executes the value in parallel. So they're going to be running in parallel. And as a result, the peak throws his hands up and says, you know what? I'm stateless. Anytime you call me, I will perform the consumer, in this case, print, and it just prints it. But you say, you're scratching your head, well, I'm in a parallel stream. I want to debug this, but I want to look at it in order of the computation, order based on the stream or the source. So, how do you implement an ordered peak in a parallel execution? Well, that's what I want to show you here is a peak in order, right? So let's go back here and guess what I'm going to do with this particular example? I'm going to change this right here to a gather. And to gather, I'm going to say peak in order. And I'm going to implement my own custom peak in order function. So peak in order. So I want to perform peak, but I want to do it ordered, if you will. So that's going to be my custom gatherer I'm going to implement. Again, I'll just accept the generated code by the IDE, but we're going to come back and fix it. So in here, I'm going to say this is going to take an integer. If you really want to, you could make it a generic as well. That's a little bit more power to you. You can do that if you want to. In this case, it's still stateless, and it's going to be really an integer as well. And peak in order, what does it take? You know this already, right? It takes a consumer, which is going to take an integer as an argument, so that's your consumer. So what does the peak actually do in that case? Again, go back to the fundamentals we talked about, right? Not customer, but consumer. Pardon me. I'm at a client site. Maybe my word is customer right now. So consumer, there we go. Let's bring that in. So essentially, consumer. There we go. I'll eventually get this right. There we go. So what am I going to do within this particular function? Well, remember, you do your work, push downstream, convey what the downstream says to the upstream. That's exactly your job, isn't it? So return gatherer dot off sequential. Obviously, you wouldn't put parallel here because if you want parallel, you already have a peak, right? Why do you want to implement it? So what are we going to do within this? I'm going to say this is stateless. I'm going to take an element. I'm going to take the downstream again. So that's my downstream. We brought those things in, as you can see right there. So then what is the operation we want to perform in here? With those three things coming in, the operation is, I'm going to say that we have a consumer, right? But I got to make a few decisions, and Salim is watching me, so I cannot put curly brace here, right? So because Salim is watching me, because we have discipline, I'm going to say consume and push. And I'm going to send the element, send the consumer and the downstream to that particular operation. So we can see consume and push. What do we do in the consume and push? The consume and push function tells us we want to consume the data given to us and then push it to the next step. That is two lines of operation, isn't it? So we are going to say in here, the first response here is, we'll just take those and say, consumer dot accept the element and then return downstream dot push element. See if that makes sense about what a peak, custom peak is going to do. What does a custom peak do? Takes the data given, sends it to the consumer, pushes the data downstream and says, you do what you want to do with it. And then whatever the downstream's wishes are, returns to the caller. Now, in this particular case, as you can see, pardon me, this is going to be, I think my ID messed up here a little bit. But as you can see, I could have put a curly brace. I could have said consumer.accept element and return, in this case, downstream.push element, right? But we don't have to do that. Why? Because that encourages us to write multi-line lambdas, and we made Salim very unhappy. We don't want to do that. So we are instead saying, you know what? I'm just going to call a function which is going to do the 2 lines of code so we can keep it nice and clean. So we just wrote that function and passed it down, right? That's a discipline I was talking about earlier in terms of what we can do. So when we run the code, the top part is the peak function. Notice the values are in whatever order they are received in, because peak does not guarantee ordering. But this is our custom peak we wrote. Notice the order is exactly the same as it was in the original. Why is that? The reason is we said off sequential. So again, what does this actually do? To understand what it is doing, if you're in a parallel execution, it brings the elements to a sequential flow through that construction point, as I used in the analogy, and then it's parallel again. So the stages before the peak custom, or whatever they are, parallel or sequential, the stages after the peak are whatever they are, parallel or sequential, but the peak custom itself is sequential.
Yeah.
Billy, that's an example that shows the power of the gatherer in terms of the sequential versus parallel.
Exactly, and I just wanted to pop in that Adam asked basically a question of a real world example of why you might need to do it the painful way, and that's kind of what you just answered here over the past 5 minutes. So I just kind of wanted to pop in just so that question, well, you are answering it anyways, but
Yeah.
if anyone was curious as well.
Oh, totally, right? To Adam's point, the reason you want the more painful way is you really need that performance, if you will, and you really need to do that in parallel. In the peak custom, that wouldn't make any sense, because the goal of peak custom was to make it sequential. But imagine you are dealing with parallel operations, and you want to process those elements in parallel, but you also need to carry a state across. An example of that, Billy, is the reduce function. The reduce function works in parallel. It computes the values in chunks and then merges it in. So the JDK team has taken the pain to implement reduce in a parallel way, but it's a really complex code. So performance, I would say, is the reason. But to Adam's point, when it comes to performance, maybe it's worth emphasizing this, right? So I want to really emphasize it. When it comes to performance, it is not about how fast the code is, but it is about, I would argue, if the speed is adequate. Adequate. So the question you want to ask really is, if you're able to implement it sequential and get the real performance, stay with it, right? If the sequential doesn't give you the performance, but if your parallel stateless works better, stick with it. If you say, you know what, my business is still unhappy because this performance is not adequate, only then take on more pain. So to go back to Adam's question, if the performance is adequate, please don't take that extra pain. If the performance is not adequate, then incur the time and effort to implement that code. In writing the book, I actually talk about this, and I tell developers, your solution is to come up with the simplest option first, make it work, and make it better real soon. If the simple solution is adequate, please don't go any further with it, because you have increased your cost of development a lot more, and you may leave the team, somebody else inherits the code and they become the victim of the code you leave behind, right? So ask the question, if the performance is adequate, don't bring in more. It's going to be really dangerous in that case.
Yeah, no, I mean, that's an excellent point that I think, a lot of particularly younger developers can run into when it comes to performance. It's like, let's say you are building a web application, like it's currently like a 1 second, like, like someone hits submit on something and it gets back in a second. And let's say of that second, like a tenth of a second is going through this stream and, optimizing it, you get it from like a tenth of a second to 50 hundredths of a second or something. So like you reduce it by half basically. But like for the user, it's like, okay, now they're going from a 1 second response time to a 0.95 second response time, and they're not going to notice a difference. So like you're doing, just to exactly your point, all this work, and you might be really making your code difficult to read without any really apparent benefit to the user, even though you made it twice as fast.
Totally.
Yeah.
I think that is where the difference between knowing versus wisdom comes in,
Yeah.
right? So we need to, knowledge without wisdom is dangerous. And I think you made an excellent point about it, is we need to really examine that and be wise about it. So I want to quickly mention, and then maybe take a few questions if
Yep.
there are any, about map with index. But I'm going to only mention this here, not go to the example. But what I want to mention here is, this is where you would modify this underscore to bring in a state. So this is where a stateful comes in. And what you're going to typically do in this particular case is, you're going to inject a state, which means you need to know what to do initially. So this would be an initial state you bring in, and your implementation of the the integration phase needs to update that state and return that state back. Well, actually, it's going to update the state and it's going to keep the state internally. You got to be a bit careful how you implement it. Now, remember, we say don't do mutation when it comes to functional pipeline. So you may look at this and frown upon it and say, oh my gosh, you're mutating. But keep in mind, this is not a mutation that's visible outside of the stage. So you're going to create a state, you're going to initialize the state in here, and you're going to modify that state within your implementation, but that state is kept within the stage alone, and it's not leaked outside. It's a bit more complex to implement, but not something impossible to understand. But I would just encourage you to, if you're new to gatherers, my recommendation is play with stateless to begin with, and then play with the sequential to begin with, then come up with the state and sequential and play with it, and then eventually gravitate towards parallel. That would be a nice transition path. So I hope these examples gave you a good understanding of what gatherers do and how we implement it. And definitely, I wouldn't implement a parallel in here in this session, because that's a lot more complex. And I would say ease into it over time rather than jump into it. And you want to take the time to work through it, if you will.
Nice. So we have another question from Salim. He goes, I thought about implementing a distinct by ID, like with a gather API instead of distinct, because they don't often write a good equals and hash code. Would this be a good idea? Is it feasible?
So the feasibility is yes, but is it a good idea? I would say it really depends on the exact need. And I would also explore if there are other built-in functions that can do it. And Salim really has a tactful way to ask really good questions, I think. To give you an example of this, Billy, is I had somebody email me and said, look, I wrote a custom gatherer. What do you think? And my response to them is, I'm really sorry, but I can implement your code by using the built-in functions already. You didn't have to write this gatherer. So I would say, I'm not talking about Salim not having an open mind, but I would say have an open mind in general, and ask the question, can I implement this without gatherers by using built-in functions already? So my first recommendation is use built-in functions. Second recommendation, use built-in gatherers. Third recommendation, write your own custom gatherers. If you decide to write your own custom gatherers, then go through the sequential versus parallel and the stateful versus stateless, and then decide which one is less painful. So I would take these in stages, and I may appear that I'm discouraging use of gatherers, and to a point I am, because this is a very powerful concept. You don't want to just jump into it without really knowing what you're getting into. You can play with it, experiment with it. I always say there are things I do for learning purpose, and there are things I do for production purpose. And if I need to put in production, I would ask the question how easy or hard it is to maintain in the long run. So I would say play with these, learn all you can about it, and have the wisdom when to bring them into production and when not to. That's what I would say.
Yeah, no, absolutely. Yeah, it's always important that we have to dedicate. We give you some new tools to use. It's important to just not get overly eager and then start to use that new tool in every possible location. Sometimes we kind of saw that a bit back in the day when like we would first enter lambdas, and then like everyone was eager to change everything to lambdas. Actually, that does remind me. There was a question a little bit back. Yes. Okay. Yeah. From Super Spot. Should gatherers replace reactive patterns like Reactor or RxJava in some cases?
I don't think so. And
No.
and the reason I don't think so is the reactive patterns are solving a completely different problem than this one.
Yeah.
They address back pressure, they address asynchrony, so they are not going to be really relevant to solving the problem. So if you really have a need for the reactive API, then there could be other solutions that may address that, but not gatherers itself.
Yeah. Actually, Salim also kind of mentioned it. Unfortunately, it's not quite here yet. I was also hoping it was going to be finalized. So I kind of knew it was going to be for 25 is the structured concurrency API, though we also still have virtual threads, which, could be something for kind of replacing some of those uses of reactive. If you're not a fan of the reactive style, which I'm not, but of course, if you are, that's fantastic.
Yeah.
So, okay. Yeah, I guess maybe a good thing to end on would be, so how do you keep up with all these new JDK features? Yeah, how do you do it? I always kind of wonder that as well.
It's like being dropped in a pond and you don't know swimming, and you beat your hands as fast as you can. So to me, learning is a non-linear process. So I don't learn methodically. That's kind of the difference between studying versus learning. I think studying, there's a method, you need to follow these things. Learning is lifelong. So I usually let two things drive me. One is my curiosity, my interest. So I kind of look at stuff that are interesting. The other is based on the need of projects I'm working on, and if there's a need for it, then I dive in. And I think that works really well, because when you're curious, you're motivated to learn. When you have a need to use it, you're motivated to learn as well. And motivation is such an important thing in learning. When we're motivated, I think we learn more productively. So I don't have a method that by which I actually learn. And so that's basically the approach. But I do want to
Yep.
say that, Billy, you made this so much fun. I really want to
Yeah.
thank you and the people with questions. A lot of times I don't do online anymore, mainly because it becomes so boring, and
Yeah.
I get so demotivated talking about motivation. But definitely you and the people who are asking questions, you made this absolutely a fun for me. I cannot thank. I'm very grateful. Thank you.
Yeah, I appreciate those kind words. I know what you mean, but also thank you to the audience for asking so many great questions. I'm glad that people quickly took the hint to definitely ask questions. It's like sometimes, yeah, you get to the end and no one has questions. So it's like you either gave like the absolute best presentation that answered any possible questions, or more likely people were doing something else. So thank you so much.
Yeah, and thank you to both of you for taking the time. And yes, again, thank you to the amazing audience. And once again, if you are watching this after the live stream, head over to our Slack channel and drop your questions there, and we'll be sure to get them answered for you. But thank you both so much. And to the rest of the community, our next session will be on June 11th, where we will be joined by Aisha Lafia, who will be chatting to us about building sustainable software with Java. So looking forward to that. Make sure you sign up, and hope to see you all there. Thanks again for watching.
Thank you. Thank you, everyone.